Hi guys, my name is Valentina Tejeda,
Hello, my name is Kalini Bonaparte.
And I'm John de Guzman.
and we're going to be talking about the last question on the hands-on homework, which has to do with the force one, which is 40 newtons, transferred into UMV components, and we use two methods, graphic and analytical method.
Right. So for graphically, what we just did is that we provided a unit for force of 1. And so we made that unit 1 centimeter equals 10 newtons. So we just measured out force 1 to be 4 centimeters. And now we just took it and physically measured out U and V components using a ruler. And we found V to be around 5.7 centimeters, making it 57 newtons. And the same thing with our U component, making it 7.6 centimeters, making it like 7.7 centimeters, which was 77 newtons. And a quick thing to clarify is that for the V component, it is negative 56 newtons just because it's moving the opposite direction on the V axis. And that is the graphical method.
Okay, I'll be doing the analytical. We'll be using the graph to figure out using parallel lines according to each of V and U to find out the angles using angle theorem. Using the parallel lines, we were able to figure out this triangle here, which each side would be correlating to F1, F1U, and F1V. With those, we get the degrees, and then we could be able to figure out using the law of sine. So we were given for F1, it would be 40 newtons over sine of 30 degrees, which would be also equal to F1U over sine of 105, equal to F1V sine of 45 degrees. And then we put these into equations. For F1U, it'd be sine 105 over sine 30, times 40, we get a decimal of 77.274, and we round that to 77.3 newtons. For F1V, we do sine of 45 over sine of 30, times 40, we get 56.568, also rounding it to 56.6, and then we'll make it negative because V is going in the negative direction, making it negative 56.6 newtons.
All right, and then for the percent error, what we would do is we would take the graphical value minus the analytical divided by the analytical. So for F1V, we have 57 negative or positive. It doesn't matter because you get the absolute value anyway. So it'd be 57 minus 56.6 divided by 56.6. And then multiply it by 100, which gave us 0.70%. And then for the F1U, we took 77 minus 77.3 divided by 77.3, multiplied by 100, and you get 0.39%. And both of these methods help us come to the conclusion that solving it together and separate helped us put our answers together and figure out different ways on how we could solve it. And yeah.
I completely agree. I think doing it individually, we're able to try to figure out the problem on our own, and when we come together, see any similarities or differences that we may come across. And graphically, we're able to visualize it better, while analytically, we're able to see more precise calculations.
Mm-hmm.
I also agree, but I also believe it is important to know to figure out what you're doing, because for example, I had completely different values for that U and V components compared to both my group members, and it caused my percentage errors to be extremely high compared to the ones we went with. And I also believe working on it on your own helps you figure out as a student and as a upcoming engineer to figure out what's your strengths and where your weaknesses.
Exactly. Thank you guys.
Thank you.